Okay, here's another concept for you. Independent variables and dependent variables. Now, it's really, to me, shocking how often people don't understand the difference between an IV and a DV. And so I'm going to state this as simply and as clearly as I can and just say this. An independent variable often reflects treatment. It's the difference between groups based on what you have done to those groups very often. For example, an independent variable might be for headache treatment, might be aspirin or sugar pill or a kick in the shins, okay? Now just think about that for a second. Surprisingly, by the way, a kick in the shins can be good for a headache because of the gate theory, which says that it's hard for people to attend to more than one thing at a time. Not that I would want that particular medicine if I had a headache. But do you understand that the treatment that you get is the independent variable and it separates the groups? You're either in the group that got a sugar pill, the group that got aspirin, or the group that got kicked. Okay? The dependent variable is what you observe. And an example of what you observe might be, on that study that I was just talking about, might be how much does your head hurt on a scale of 0 to 10. And so what you would eventually have if you ran such a study, other than a bunch of irritated people with sore shins, is you would have 3 groups who would have given you their pain scores on a scale of 0 to 10, and you could then compare those 3 groups. Using, in this example that I'm giving you, you would use an ANOVA. But we'll get to that later. But for now, I just want you to understand that the independent variable separates the groups, and the dependent variable is what you observe. And I want to say that some variables, though not technically independent, are called independent variables. Let's just take gender, okay? I can't randomly assign the gender of male or female to my participants. They come in with that gender already assigned. And so, but that is, for our purposes, called an independent variable because it separates the groups when we do our analysis. Also, I want to point out that even though a variable might be independent, it might be, each person in the experiment could potentially be in all levels of the independent variable. For example, let's say that we have somebody and we tell them, anytime you get a headache, come into our office. Then when they get there, we either give them aspirin or a sugar pill or a kick in the shins, depending on our treatment protocol. And eventually what we'll have is a group of people who have come in 3 times each, and they've gotten one of those 3 treatments each time. And so even though it's the same person who's being measured 3 times, that is still the independent variable is the type of treatment. And this is just the difference between what we call a between subjects design, which would be different subjects get aspirin versus sugar versus kick, versus a within subjects design, which is the same subject eventually gets all 3 levels of the independent variable. So that's the difference between independent variable and dependent variable. The next concept that I just want to discuss briefly is the difference between population and a sample. We don't know what the population of sex offenders looks like on the penile plethysmograph because we haven't given a penile plethysmograph to every single sex offender out there. What we do know is what a sample of sex offenders looks like on the penile plethysmograph. And that's sort of what we're limited to in science very often, is looking at samples and not really knowing what the population is like, because it's just impossible to sample the whole population unless you define the population in a very limited way. For example, I could say that the population of sex offenders who are incarcerated at Coalinga State Hospital look a certain way on the penile plethysmograph, because it would be doable to give all of those people the penile plethysmograph. So if I define the population in a very narrow way, then that makes all the difference. But very often what we're trying to do in statistics is make inferences about the population based on our data that comes from a sample of that population.